Hello students, welcome back. Now let's go to section 4, Algebra Essentials. Here's a summary on algebra of fractions. Multiplying two fractions. Let me expand the font a little bit. There are too many fractions, so I cannot read very well. Alright, multiplying two fractions. Just multiply the numerators and denominators, that's it. Division can be a little bit trickier, but if you just remember one thing, division is essentially the same as multiplying the reciprocal, then that'll do it. Just flip over and then multiply as before. Multiply the numerators and multiply the denominators, and that's it. Now, addition and subtraction can be a little bit trickier because we have to take the common denominator. And division within a fraction can be a little bit confusing, but in the end, you can remove all those denominators except for the outermost one. So how do we do that? We just multiply the same thing to both numerator and denominator. And what do I multiply? We strategically select the product of the denominators, b times d, and then you'll see this b and b canceling out, and then we get d, and in the denominator we get this d times d canceling each other out, and we just have b times c, and the result, we get denominator of denominator, denominator of numerator. Oh, too many fractions. Here we have only one fraction, so it's a lot simpler this way. Absolute values. Not much there, just take the number part. So absolute values make everything positive. If it is positive, keep it as positive. If it is negative, then extra negative will make it positive. No big deal there. And if you need to deal with some geometry here, a minus b absolute value turns out to be the distance between the 2 points. Okay, alright. Another review that I'll go over very quickly, a to the nth power is basically repeated multiplication. And 0 power is defined as 1. So think of it this way. Start from 1 and multiply nothing. 0 is nothing, right? Start from 1 and multiply nothing. Then you get 1. So a to the nth power, you can regard it like this. Start from 1 and multiply a n times. So start from 1 and multiply a n times. If you multiply once, then you get 1 times a, that's a. Multiply twice, then 1 times a, so a squared like that. But then again, if I multiply nothing, then goes to 1, not 0, goes to 1. Remember this, please. I sometimes see mistakes. Now, negative power goes to denominator, and that's something that everybody should remember, and that's just a definition as a matter of fact. People decided to use it this way, and it turns out all those computation became simpler this way. That's why people created this kind of notation. Negative 1 power is basically reciprocal, and negative, say, 10th power is 1 over a to the 10th power, for example. 1 over, say, 2 to the negative 10th power is basically 1 over 2 to the 10th power. Kind of like that. So negative power is power in denominator, basically. The radical becomes fractional denominator. Fractional power is a radical. So for example, if you have 5 to the 1/3 power, that's actually the cubic root of 5, for example. And then what if I multiply the same thing 4 times? Then that becomes multiply by 4, 4/3 power. So this is going to be like this. And that's what I have over here. But special case when m equals to 1, 1 and then just 1. So 1 power, so I don't have to write it here. So what do you get? You just get a radical. So fractional power is the radical. Negative power is the denominator. Exponent rules, and these three are the standard. I don't see a lot of mistakes here. In intermediate algebra, even there, students didn't make many mistakes about these. So I'll just move on. And not much about this one either. Just repeated multiplication distributed around. So as for these exponent rules, I'll just move on. These, I see some mistakes, and here again I see some mistakes, and rarely, but I do see some mistakes here. That's why I emphasized in those colors. But here I usually don't see any kind of mistakes, so let's just move on. Now, one final comment. Common mistakes on addition. You see, the first line here, the distributive law, that is one of the rare case that works. So here, a times b plus c, I can separate. And that comes from the distributive law. And as for this one, this too is coming from the distributive law, as a matter of fact. We can separate the numerator because this is basically multiplying by 1 over c. You see down here? Instead of this, you can consider it as the distributive law, and 1 over c is being distributed into a and b like this. Distribute, and then we end up with the right-hand side. But of course, who has time to go through all the proofs? You can go directly to this. Whenever you have addition or subtraction in the numerator, just split those out. Otherwise, oh no. You see, the distributive law works either for multiplication or division, and deep down they're the same thing. But that is one of the rare cases, actually, quite possibly the only case. Otherwise, all no. Square doesn't work. Cube doesn't work. Radical doesn't work. Denominator doesn't work. Curiously, if you change all these into multiplications, then they work. And as for these down here, I usually don't see any mistake from students. But from here, I see a lot of mistakes in all levels, actually. I even see these kind of mistakes in calculus classes, actually. They usually don't make this kind of mistakes, of course, but when they are stressed out, like when they're taking exam, and the kind of algebraic operation they are doing is worth really a lot. In that case, by some stress, students make these kind of mistakes. So in short, they don't usually make those kind of mistakes when it doesn't really count too much, but they do make mistake when it really counts. Kind of paradoxical, but there's no paradox there. It's exam psychology. So how do you avoid those kind of mistakes? Remember these, and then a lot of practice. That's about it. As for practices, I'm not going to spend time doing practice here in this lesson because these are all preliminaries. I'll just dump over everything to my MATLAB exercises, and then we'll say section 4 is done. Let's meet again in section 5.